Welcome back. We are moving on to section 4.5, which goes over standard form. We've already talked about slope-intercept form, and now we're going to talk about standard form. The first thing we need to talk about is an x-intercept and a y-intercept. So an x-intercept is a spot that a graph crosses the x-axis. In this case, you're going to plug in 0 for y and solve for x. And then a y-intercept is a spot that the graph crosses the y-axis. You would plug in 0 for x and you solve for y. If you look at the graph, it is actually just the locations where that line crosses your x-axis and crosses your y-axis. Typically, it will go through, for right now, it will go through a perfect point. We will get to the point where it does not go through a perfect point. So you are going to go shopping and you're going to buy X amount of t-shirts for $12 each. And you're going to buy Y amount of t-shirts or pairs of pants for $24 each. You're going to spend $84. First thing you need to do is to write an equation. Standard form is often used for writing equations. So I'm going to do 12x because I know that's how much my t-shirts cost. And I'm also going to do 24y because I know that's how much my pants cost, and I'm going to spend a total of $84. Well, what I need to do is I need to add those two together because 12x plus 24y is going to equal the total that I spend together. To find the x-intercepts, you are going to do a couple of things. The first thing I'm going to do is I'm going to plug x in, or 0 in for x to solve for y. I'm going to do this below. You can go ahead and write it right here, but my pen does not work very well, so I'm going to write it at the bottom and then move it up. So I'm going to plug in 0 for x, and I'm going to get 24y equals 84. So 12 times 0 gives me 0, so that's going to cancel out. Now I've got 24y equals 84. So I need to divide both sides by 24. And if I use my calculator, it's going to tell me that y equals 3.5. From here, I'm going to go ahead and shrink that down. From here, I can also do the same thing, except this time I'm going to plug in 0 for y instead of x. So I'm going to do 12x plus 24 times 0 equals 84. So I know that this goes away. I know that 12x equals 84. And I'm going to divide both sides by 12, which that will cancel. And I know that x equals 7. Okay, again, I'm going to shrink this all down, move it up to where you should have it written. And there we go. What this is telling me is that since x is my y, or x is my shirts and y is my pants, this is telling me that if I just bought shirts, I would be able to buy 7 of them if I just bought shirts. So on my x-axis, I'm going to go over to 7 and I'm going to plot a point. And then it tells me that if I just bought pants, I could buy 3.5 pairs. So I'm going to go to my y-axis and I'm going to go up to 3.5 and I'm going to plot that point. From there, I now have 2 points. And I can graph my line, which will go right through these 2 points. And so that is my line. Now, what the next question is asking me is it says graph your equation, which we've done, and find 2 other ways. Well, we need to first of all make sure that we label our graph. So I need to say that this bottom, the x-axis, that tells me how many shirts. And over here I've got my pants. And we know we can't really buy 3.5 pants, so that doesn't work very well. But I want to find a place, and my line may not be perfectly straight. This is where a ruler is really going to come in handy. I want to find 2 other places where I have perfect coordinates. So those locations would be, I'm going to change the color so you guys can see this. So those locations would be, I think right here is a perfect one. Oops. And right here is a perfect one. Now, that's going to tell me that my ordered pair would be 1 shirt and 3 pairs of pants. Or I could have 5 pairs of pants and 5 shirts and 1 pair of pants. And so those are 2 other ways that I could, let's shoot it down here, that I could have spent my money. Where I have 1 shirt, 3 pairs of pants, 5 shirts, and other pairs of pants. There's also another one on there that could work as well. And that one is going to be right here. So I could buy 3 shirts and 2 pairs of pants. And so that's what it's going to tell me. So that's one way that you can solve for the standard form. Another way you can solve for standard form is called a cover-up method. And the cover-up method is essentially doing the same thing. You are just going to basically cover up. So to solve for x, I'm going to cover up my y. So just imagine that this is covered up and no longer there. So now what I have is 3x equals 12. Well, in this case, I know that x equals 4. So I can go to my x-axis and go ahead and plot it at 4. And on the other one, I can say that if I want to cover up, if I want to move my cover up to the other side, so now that 3x is gone, I now have a negative 4y equals 12. So if I divide by a negative 4, y equals a negative 3. So I can plot that point on my y-axis at negative 3. This works really, really well when they both work out to be even numbers. And so that is my graph right there. You see it crosses both the x and the y-axis. We can do the same thing again on the next side. Let's get our highlighter back out. If I cover up, and it doesn't matter which one you cover up. So this time I'm going to cover up my y first. So now I say, well, that's a negative 5x equals a negative 20. So x equals 4. So I go to my x-axis and plot that point on 4. And if I want to move my cover up now over to the other side, and you can just use your finger to do that, that is going to give me 4y equals negative 20, which y would then equal, I know, a negative 5. So I divide both by 4. Should be down here, and I can graph my line. Okay, moving on to the next page. These two are not in standard form. So if you go to your original on the first one, you can graph that with slope-intercept form. In order to get it to standard form, though, we need to get ax plus by equals c. And this is what we were trying to avoid all last week. But now what I want to do is I want to subtract my 2x from both sides. So I have y minus 2x equals 5. And in this case, if I want to cover up, it's not as friendly. I can always do my y. So I can cover up my 2x. That's covered up. Now I have y equals 5, which is an easy one to graph. But when it comes to my 2x, that's where it gets a little bit trickier. So I've got negative 2x equals 5. So if I divide that by negative 2, I get 5 over 2. So x equals 5 over 2, which I know is a negative 2.5 or 2.5, which I can graph right here at the negative 2.5. And I can go ahead and draw my line there. The only thing is we know that that's not exact perfect. Oops, my line's a little off. But it's pretty close. So now if I have an equation that is just has 2 terms, has an x and a y, what I'm going to do is I'm going to add a 0. And I'm going to go ahead and put it in standard form. So I have y minus 3x equals 0. Now I need to set each one alone. So let's go ahead and let's use that cover up. The easy one is going to be y. So in this case, y equals 0, which is very simple to graph because I go through my y-axis at 0. And then if I want to do my second equation, y minus 3x equals 0, and I cover up my y in this case, I now have negative 3x equals 0. So I've got to divide by negative 3, which gives me x equals 0, which would be at the exact same location as before. Now, I can't graph that and it doesn't give me a line. So I have to resort back to what I already know. And what I already do know is that y equals mx plus b. That b is going to be my y-intercept, which I know is 0. That m is going to be my slope. So in this case, my slope is 3 over 1, or 3 over 1. So I'm going to go up 3 over 1. Up 3 over 1, and from here I can still graph my line. If you get to a point that's really tricky like that, make sure that you're looking, because it is important that you do have a line graphed and not just an imaginary line there with one point. We'll talk more about it in class.